Hi everyone, welcome to Learning Math with VK. Today we explore lesson 26 in algebra, compound interest formula and the Euler number E1 compound interest formula. Okay, let's say that if you invest P money into an account that offers interest rate or after T years, then the amount in the account is it will be this amount. A is initial investment plus interest. Initial investment is P. The interest is P multiplied to the interest rate multiplied to the time T. P or T. This formula right here, let's call it the simple interest. Now, let's say you put $100 into an account that pays semi-annually at 6% interest per annum or per year. How much money do you have in the account after 1 year? To do this one, we need to know two things here. The semi-annually. Well, semi-annually means that interest is compounded 2 times each year. And 6%, 0.06. We can get a table and figure it out. The compound period amount in account well, we have the first half, that is 6 months. The amount in the account would be P plus P or T, and this P is 100 plus 100 times 0.06 times 6 months is 1/2 of a year. So this would give us $103. In the second half, that is 12 months or exactly 1 year. The formula P plus P or T. P here is 103 plus 103 times 0.06 times 102. And this would give us 106.09. What we want to take a look at is that if P is invested into an account that offer interest rate or compounded n time per year, then each compound period is 1/n of a year, and the interest would become PRT equal to PR. T here it would be 1/n per compound period. So that would be P times over N. That's the nice formula. Interest per compound period. Now we are ready to take a look at the compound interest formula. Okay, so we have the compound period. And then on the other side, we have amount in account. The compound period, first period is 1/n year. So we P plus P times over N, which is P, you can factor out the P and then you have 1 plus over N. Second, compound 2/n of the year. So this would be P 1 plus over N plus this amount multiplied to over N. So P 1 plus over N multiplied by over N. And we can factor out the common factor. P 1 plus over N. We have 1 plus over N, which gives us P times 1 plus over N square. In the third compound period, it will be 3/n of the year. And we would have P1 plus over N to the power 2. So eventually we're going to get to end compound period. So that would be N/n, which is 1 year. And the amount in the account is P1 plus all over n to the power n since t is t years half NT compound period, the amount compounded n times per year after t year is ta-da, 8 of t equal to p 1 plus all over n, and we have nt here. Let us call it the compound interest formula. Next, we use the compound interest formula to derive E, the Euler number. So in order to get to the Euler number, we have to suppose n get bigger and bigger. That is the compound periods. It's getting bigger and bigger in 1 year. What will become of the compound interest formula? Let's take a look. So the formula is AT equal to P times 1 plus all over n to the power nt. We're going to have to do a little rewrite here. So P times 1 plus, instead of writing over n, we can write 1 over n of r nt. Yeah. Next step is, because r is non-zero, then we can write this as P times 1 plus 1 over n of r to the power n of r or t. Yeah, it's the same thing. N over r is the real number. So we're gonna let h equal to n over r. And then from here, we have P 1 plus 1 of h or t. Yeah. As n get bigger, h get bigger. H 1 plus 1 over h to the power h. And h equal 1. We do the substitution. So that 1 plus 1 over 1 to the power 1, which is 2. when h is equal to 10, 1 plus 1 over 10 to the power 10, and we get 2.5937 100. Then we get 2.7048 1000. We get 2.7169 10,000, and we get 2.7181 100,000. We get 2.7182, and if we keep going, then eventually we're gonna get to a number E. Meaning that as h approach infinity, then 1 plus 1 over h to the power h would become E, and that is where the number E is. In calculus, we write this as limit h go to infinity, 1 plus 1 over h to the power h. This would be E. Euler is the first person to roll down E and prove that it is an irrational number. So that is why we call E an Euler number. So once we know this, the formula would become AT equal to P E to the RT, and this is called the continuous compound formula. E is very useful in the later section when we study exponential function and logarithmic function, because similar to how every number can be considered as a scale version of 1, every rate of growth can be considered as a scale version of E. And interestingly, E appears whenever a system grows exponentially and continuously, such as interest compounding, population, radioactive decay, object cooling down. And because E occurs so often in nature, we call it the natural number. Thank you for watching. I hope you found the content useful. Please like and subscribe to help the channel grow. I'll see you in the next video.